Hello, beautiful people. Today we are covering 4.6, formalizing relations and functions. Our SWABAT is going to be to determine whether a relation is a function, find domain and range, and to use function notation. Vocabulary: relation. That's any set of ordered pairs x and y. So it could be 3, 4, 2, -1, 5, -4, 3, -2. It's any combination of numbers paired together. It's typically in the form of x, y with the parentheses. Domain. I don't know why this is bolded, but it is. It looks good. Those are the values for the input of a function or a relation. So for this relation, for example, our domain would be the set of these numbers. The input values are 3, 2, 5, and then see I already wrote the 3, so I can write that again. So your input values are the first portions of them, the x portion, which is also known as your input values. The range are the possible values for the output, or the dependent variables. Those are the y, because y depends on the x's of a relation or a function. So for us, given this relation, the range would be this set. So this right here, these are brackets with, I don't know what they're really called, brackets. It's going to be 4, -1, -4, and -2. All of the output values are going to be your range. So 4, -1, -4, and -2. Okay, so the difference between a relation and a function. So all relations are functions, but not the opposite. Functions are basically special types of relations, and they're relations such that exactly one value in the range goes with each value in the domain. So if I'm looking at this previous example, how I have 3 going with 4, 2 matches with -2, 5 matches with -4, and then 3 right here also matches with -2. This is not a function because 3 has 2 different output values. Not a function. But it is a relation because we could be related, but we don't function that way. Okay, vertical line test. We're going to use this in a little bit. Some of you have heard of it before. This is a method used to determine if a relation is a function or not. Vertical line. So remember, vertical lines will always go like this, up and down. It's a vertical. And the question is typically, if that vertical line passes through the graph more than once, then the graph is not the graph of a function. So if I had something like this, for example, if you could imagine a vertical line moving from left to right, does it cross more than once? Absolutely not. So this one would be an example of a function. Something that would not be a function, something like the letter S, which is kind of like what that is, but not exactly. Because if I'm thinking about a vertical line, I can see that like it would pass 1, 2, 3 times, super not allowed. So the vertical line test would just tell me whether or not a graph is a function or not. Scientific notation. Just kidding. Also known as function notation. Got ahead of myself. That's when we're basically going to be replacing the variable y with f of x. We read it as f of x. It's not f times x. The letter f is the name of the function, not a variable. So this is not f times x. You can't divide this by x because this is the function. This is its name. This is its new government name. Y is kind of like the nickname of it. Function notation is used to emphasize that the function value of f of x depends on the independent variable x. This function f of x, which we used to just call y, depends completely on x. Whatever x is will determine what f of x is. We will also use other letters aside from just f, such as g or h. So we would say g of x, h of x. And it's like saying the function g when I plug in x. The function at h when I plug in x. This function f when I plug in x. Why? Because it depends completely, solely, and wholly on x. Okay, so for this first one, if you could please, given what we just talked about up there, identify the domain and range of each relation. So what I'd like for you to know or tell me is what's the domain and what's the range. And I'm going to use this set. And then we're going to use a mapping diagram to determine whether the relation is a function or not. So domain, remember we said were the first numbers. So 5, 2, 4, 3. Excuse my handwriting, it's not the best. And then my range is going to be my output values. And my output values are 5, I don't know why this is so bold, -4, I'm only going to list it once, and then -1. This is my set. Sorry. Okay, so your next question is, use a mapping diagram to determine whether the relation is a function. So here's a mapping one. I first have this number 5, and 5 goes to what? Well, 5 goes to 5. 2 goes to -4, 4 goes to -4, and 3 goes to -1. They're all being mapped to one different number. None of these are saying the same thing, so I'm going to say yes, this is a function. This relation is a function. For the next one, go ahead, take a moment and define your domain. 3 is already said, so I won't say it again for this one. And then 7. My range are my output values. So -2, or the y values, 4, 0, and 1. And now to map. So I have 3, that's going to -2. I have 1, that's going to 4. And then I have 3 again, but now it's going to 0. And then I have 7 going to 1. Houston, we have a problem, and my problem is with that 3. That 3 is telling me two different things, basically. It's telling me 0 and -2. It's like being two-faced. So because of this, this is not a function. Every input has to have only one output. Just one. Can't be two-sided. Clearly I have some issues with that. So the next one, use vertical line test to determine if it is a function. So please take a moment, go ahead and review what we just said up here about the vertical line test. You can only hit once throughout, and then determine for A and B. So thinking at A, vertical line test, looking at it from up and down, does a vertical line anywhere hit more than once? Not so much. So I'm going to say, yeah, this is a function. Whoa! Function. Looking at B, here's a counterexample. Like here's a vertical line test. Notice here it hits more than once. You could do this with several different ones, like bam, bam, bam. You only need one though. And that proves my point. As long as it hits more than once anywhere on here, this is not a function. All right, very good. Next part, determine whether the relation represented by the table is a function. If it is a function, state the domain and range. All right. So I'm looking at this, and -1 goes to 1. That's cool. 2 goes to -1. 0 goes to -3. And then here's my issue. Here's another 2. So right now, 2 is saying -1, and then over here it's saying, oh no, I'm actually with 5. That's not okay. Can't function like that. So this is not a function, but it is a relation. So I can identify it. My domain are my input values, my x values. So -1, 2, and 0, this set. And then my range are my output values, 1, -1, -3, and 5. Part B, -1 says -1, 0 says -1, 1 says -1, and 2 says -1. That's actually okay for me. So this is a function, because all of your x values are saying something, are saying something different. Like -1 isn't saying -1, oh, but also a +1. What matters is the x values. You don't care. Y could be anything in the whole wide world, but the x values is when you have a problem. So your domain is -1, 0, 1, 2, and your range, very short for this one, is just -1, because they all set the same thing. It's unanimous. The x will determine whether or not it's a function. You don't care about the y values so much. They could all be the same thing or all be different. No one cares. Okay, we are given a function, and we're given it in function notation. We are out here trying to function. So what they want us to do is find the range of this function given the domain. Find the range given the domain. So the domain is -2, 0, and 3. So the first one is x equals -2. I'm going to plug that in. The function, when I plug in -2 for x, because what did I do? I replaced x with -2, is equal to -2 squared minus 2. -2 squared is 4 minus 2. So the function, when I plug in -2, is equal to 2. For the next one, x equals 0, the function, when I plug in 0, is equal to 0 squared minus 2. This is a whole sentence here. Don't try to change it. 0 minus 2 is -2. So the function, when I plug in 0, is equal to -2. So I'm not dividing by 0 because this is not a variable. This is a function, a full-on function. All right, and then the function, I know I'm saying this a lot, but there's a point. When I plug in 3, is 3 squared minus 2. 9 minus 2 is 7. So what is my range? Oh, I'm glad you asked. The range is a set that holds 2, -2, and 7. Very good. All right, let's talk a little bit more about functions. Use the functions f of x equals x squared and g of x equals 3 times x minus 1 to find the values of the expression. So this 2 right here, it's fine, not really doing much for me. So I'm just going to write it. It's just 2 times, well, times what? Times the function f. So this is me calling the function f, which is this one, when I plug in -2. So f of -2, the function of -2. Well, this was x squared, but now instead of the x, I want to write -2 squared. Plus, I want to call out the function g. So what's g of x? Well, g of x was 3x minus 1, but I don't want to use an x. I want to use 3 here instead of x. 3 times 3 minus 1. And then simplify. So I have 2. -2 squared, order of operations is 4. Plus 3 times 3 is 9 minus 1. 2 times 4 is 8. Plus 9 minus 1. Moving from left to right, I have 17 minus 1, which leaves me with 16. It's a good problem. All right, last one. Function. We have if f of x equals 3x minus 6 and f of b equals -9, what's the value of b? So we want to find what's the b. Well, function and function, they're the same function, and they're using the letter f to denote that. So we're talking about this function being the same as this. Well, what's the difference between this one and this one? Can you see it? The only difference I see is they have the same name, but one has the function when I plug in x, and this is the function when I plug in b. So I'm going to write that under f of b equals -9. This is the same function as this. Same, because they have the same name, f. Can't change anything about that. So what's f of b? F of b, so going back to this one right here, kind of want to change my colors, but I'm not. F of b would be 3b minus 6, except I also know this little wonderful tidbit of information, that this part is already equal to -9. So if I want to find out what b is equal to, I'm just going to plug in the -9 and then solve. So -3 equals 3b. Dividing by 3, I find that the b is equal to -1. There you go. Thank you so much for joining me, and have a great day.